So hello students, to continue of the previous class. So today now we are going to discuss about a proving relation. Okay. So this proving relational. So there are different types of sums based on this proving relation. We are going to see one by one. In the first case, we can see that proving relation for the numbers like root 2, root 3, root 5, etc. So how to prove that root 2, root 3, root 5, these type of numbers are irrational. Okay. First, let's go with the example of root 2. So first we'll see that how to prove the number root 2 is an irrational. So root 2 is an irrational. So when we are going to prove this root 2 is an irrational, first what we have to do is we have to assume that let us assume root 2 is a rational number. Okay, rational number. And we know that the rational number will be in the form of p by q. Therefore, we can say root 2 is equal to a by b, where b naught is equal to 0 and a comma b are integers and co-prime. So this is the condition we will be taking care. So see that. So we will be assuming root 2 is a rational number. So we will be assuming root 2 is a rational number. From there, rational number is equal to be in the form of p by q or else a by b, where b not is equal to 0, where a comma b are integers and it is co-prime. Okay. And what we have to do is in the next step will be squaring on both sides. So when you are doing squaring on both sides, this will become root to the whole square is equal to a square by b square. So square and square will get cancelled. 2 is equal to a square by b square. Therefore, 2b square is equal to a square. From this we can say that a square is equal to become to b square. Therefore, b square is equal to a square divided by 2. So this is the first thing we will bring that. So here we will be doing squaring on both sides. So when you are doing squaring on both sides, here square and square will get cancelled. 2 is equal to a square by b square. From this we will write that b square is equal to a square divided by 2. So we need to get this form. From this we can say that a2 is a square is divisible by 2. Therefore, a is also divisible by 2. So here you can see that this we can take as equation 1. So now we will substitute that is a is equal to 2c in 1. A is equal to 2c in 1. So when you are substituting a is equal to 2c in 1, so this equation will become b square is equal to 2c the whole square divided by 2. Therefore, b square is equal to 4c square divided by 2. And 2 and 4 we can cancel. From this we can say that c square is equal to b square divided by 2. So here you see that we have taken that root 2 is equal to a by b. So from that we are saying that b square is equal to a square by 2. So from that we can say that a square is divisible by 2. Therefore, a is also divisible by 2. And instead of a, we have to substitute 2c in equation 1. So when you substitute 2c in equation 1, we will get the equation that is c square is equal to b square by 2. So same like previous one, b square is divisible by 2. Therefore, b is also divisible by 2. So So from this, we have come to know that. So already we said A and B are what it is? Integers and co-prime. So what does it mean by co-prime? Means it will have one as a factor. It will be having what it is? Only one as a factor. But with this proof, we have come to know that for A, we are having that one more factor. What is that? That is 2. Okay. So for B also, we are having one more factor. That is 2. So therefore, our assumption is wrong. Therefore, our assumption is wrong. That is, A comma B are co-prime. This is what we assume. Co-prime. So, therefore, we can see that root 2 is an irrational number. Root 2 is an irrational number. So, this is the way we have to keep the proof for root 2. Root 3 and root 5. Okay, so first we will assume it is a rational number. So it will be in the form of A by B. After saying this, we should explain this about A and B. A and B are integers and it is a co-prime. When it is a co-prime, we should have only one as a factor. But through this proof, we have come to know that we are having one more factor, that is 2. So because of that, what we assumed it is wrong. Therefore, root 2 is an irrational number. Okay.